Today we are moving on to, it'd be helpful if you could see this. So we are moving on to Unit 3, starting with some mean, median, mode. Fun stuff. Hopefully you all know what that is at this point in your lives. So today we're going to be looking at different ways to measure the center of a data set, some measures of central tendency, and we're going to be looking at dispersion, how spread out data is. So measures of central tendency are different ways to describe the center of data, so like the average or typical values. There's three main measures of center that we use. The first is the mean, or the average. In order to find the mean, you add up. So the mean equals, we have our sum of all of your data values. So you add up all your data values, divided by the number of data values that you have. Okay, we have two different symbols that we use to represent mean. The main one is we have an X with a bar on top. This is called the sample mean. And this is what your calculator uses when it talks about mean. But there is another symbol that has the Greek letter mu. It's like a fancy U, little X in the corner. So again, this is mu, like U2. This is the population mean. Okay, so just be familiar that both of these symbols represent the mean. Your calculator likes to use we call this X bar because it has a bar on top of it. Again, creative namings here with these mathematicians. Okay, so mean is the average. Median is the number that is in the middle when you put your data values in order. Median, your calculator abbreviates it to MED, but it is the value that's in the middle when values are in order. So if you have an odd number of data values, then there will be just one number that's in the middle. But if you have an even number of data values, you'll end up getting to two numbers that are both in the middle. So if you have that situation, you would take the average of those two numbers, so add them together and divide by 2. But we're going to find a way that our calculator will tell us all of this, so hopefully you won't have to calculate it by hand, unless you forget your calculator. And then the mode is the value that occurs the most. So there can be one value that occurs the most. That's just the mode. We can say it's bimodal if there's two values that both occur the most the same number of times, and that would have two modes. But if we have more than two modes, so 3 or more, that's called multimodal. And we just don't, at that point, there's not going to be a mode. So we only say there's a mode if there's 1 or 2 values that are occurring the most often. If it's more than 2, then there's just no mode. Okay, so these three measures of central tendency, there are certain times where one is more appropriate to use than the others. And so, which measure of central tendency should you use to describe the data when the data is quantitative and the frequency distribution is roughly symmetric? So if we have a symmetric distribution, we can use the mean to represent our data, because a mean is affected by outliers, and if it's symmetric, that means there's no outliers. So since a symmetric distribution wouldn't have any outliers, it's nice and even, nice and normal. We can use mean effectively to describe the center. If we have data that is skewed left or skewed right, we want to use the median, because the median is not affected by outliers. So if we were to use the mean when we have this skewed data, those values that are skewing your data will affect the value of the mean, whereas it won't affect the value of the median. So median would be more accurate if you're dealing with a skewed data set. And then if all we care about when we're gathering our data is the most popular value, or what value occurs the most, then we would use the mode, because by its definition, it is the value that occurs the most. Okay. And so like I kind of mentioned up here with the mean, where we had our sample mean and our population mean, there are two different types of ways that we describe data. First is using parameters. This is used to describe populations. So P for population and P for parameter. And parameters are often written using Greek letters. So that's why when we're talking about the population mean, we use the letter mu, that Greek letter mu, to represent that. Whereas a statistic is used to describe a sample, so S for sample, S for statistic. And statistics are often written using Roman letters, or like the X bar for the sample mean. Okay, so population is a parameter, statistic is a sample. All right, so now measures of dispersion. So these are different ways to describe how spread out the data is. So I can tell you how consistent or inconsistent your data values are. So first, the range. This is just where you take your maximum value minus your minimum value. So it just tells you the interval that your data spans, or how many values are in between your min and your max. Then there's standard deviation. Standard deviation tells you, on average, how far away a data value is from the mean. So if we have a large standard deviation, that means we're spread out. Our data is very spread out and inconsistent. Then a small standard deviation means our data is close together or consistent. Okay, so just like with our mean, there was a population mean and a sample mean. There's the same idea for standard deviation. Your calculator will give you both of these values. So a population standard deviation, we have a lowercase sigma with an x. That's the Greek letter. And then the sample standard deviation, using the Roman letters, is just a capital S with an x. So you have to know the difference between population and sample. Again, sample standard deviation is an S, sample standard deviation, and a big S, X. They kind of match up. Okay, and then variance is just another way, again, to look at how spread out your data is. The variance is just the standard deviation squared. So your calculator won't give you specifically the value of the variance, but it will give you the population standard deviation and the sample standard deviation, which means you can just square those values. So population variance is just the population standard deviation squared. And the sample variance is the sample standard deviation squared. So if you were given variance and you needed to find standard deviation, take the square root. So you can just go back and forth between the two. All right. So one thing we can use also the mean, median, and standard deviation for is to help us describe the shape of the distribution instead of just eyeballing it and looking at the shape. This gives us a more concrete way to determine the shape. It's still not 100% definitive, but it's a little bit more accurate than just looking at it. So first, if we have our data that's skewed left, remember that's when the tail end is taking it off to the left there. In general, our mean will be less than the median, and then the median will be less than the mode. If there is a mode to report. Again, sometimes if we have more than two modes, we say there isn't one. If we have a symmetric data set, that means our mean is equal to the median, which is equal to the mode. Again, all of them are equal, usually within about two values. If they're all within two of each other, that's pretty symmetric. Again, it kind of just depends on the data that you have. And then skewed right is when our mode is the biggest if we have a mode, which is bigger than the mean, which is bigger than the median. So the median would be the smallest. Again, using the mode in this comparison only works if we actually do have a mode. Usually you're just going to be using the mean and the median. So if our mean is smaller, it's skewed left. If our median is smaller, it's skewed right. And did I change? Nope, I didn't change it on yours. Okay, so you can also use standard deviation too to determine the shape, if it's close or not. Because again, the smaller the standard deviation, the closer your data values are. So that means your mean and your median should be closer. If you have a larger standard deviation, then your values could be spread out a little more and it would still be okay. But for right now, I don't want to focus on standard deviation. I thought I changed this, but I guess I didn't. So can you guys cross out standard deviation for all three of these? And instead, we're going to have mode. So for letter A, we'll have mode equals 11. For letter B, we'll have mode equals 18. And then for letter C, we'll just have the median equal 67. Okay, so again, A and B are situations where you would have the mode to look at. It's not always going to happen. So letter C gives you that situation where you don't have the mode to look at. So if we were just given this information and we wanted to determine the shape, so here our mode is the largest. So our mode is greater than or is close to the median. But then the median is way bigger than the mean. So here if our mean is the smallest value, that is when we are skewed left. Mean is less than the median, which is less than the mode. Okay, and then letter B, we have our mode. Which is larger than the mean. which is larger than the median. So here in the median is our smallest value, and the mean is in the middle. That is our third option up there where we're skewed right. And then letter C, our mean is 66 and our median is 67. Those are within 2 of each other. They are just 1 apart. So our mean is approximately equal to our median. That's what those squiggly equal sign means, approximately equal to. So that means we would be symmetric. Okay, so again, use the mode to help you if you have the mode. If there isn't a mode, you would just be focused on the mean and the median. Okay, so now you need your calculators. Your calculator will be able to tell you all of this stuff. All right, so we have some data here, and we want to determine all these measures of central tendency and dispersion. So in order to do that on your calculator, you're going to hit the stat button, which is right underneath delete. And then you're going to select that first option, edit, so hit enter. You should come to a screen that says L1, L2, L3. You guys all see that? Okay. If you ever have anything in L1, so once you start doing problems, in order to clear a list, if you could practice doing this now, you hit the up arrow, so the L1 title is highlighted, and then you hit clear, enter. Then it'll all clear. Don't hit delete, because that will delete the list, and that'll mess up your calculator. So if L1 ever disappears, just let me know so I can bring it back. Okay, so clear enter is how you clear a list, don't hit delete. Okay, so now we need to enter our data values into L1. So our first one is 76, so you type 76 and hit enter. And then 60, enter. We do that for all of our data values. So you enter all your data values into L1. Then once you have them all in, you hit stat again. Go over to the calc menu, so hit the right arrow once. And then you select that first option, 1var stat. So you hit enter until a bunch of information pops up on your screen. Some calculators you have to hit enter more than others. Just keep hitting enter, and then a bunch of stuff should pop up. Anybody having issues getting to that? Okay, so now on your calculator, you should be able to scroll up and down where you can see a bunch of information that it's telling you. So the very first thing that pops up with the 1var stats is the x bar. So again, that is the mean. So in this case, our mean is 72.2. So stat, calc, 1var stats. Okay, and then if you scroll down, hit the down arrow and scroll all the way down, you should see a value that's labeled MED. That is the median. And so ours is 73. Okay, now the mode is not explicitly given in this list here. But there is a way that we can figure it out when we have more data values. So I want to skip mode for right now. We'll come back to that, but leave a little bit of space underneath mode. The next one that we can do is range. If you scroll down to the bottom of that readout that your calculator gives you, you should see values that say min x and max x. Those are your minimum and maximum values. So you take your max x minus your min x. So it's 81 minus 60. To give us 21 for the range. and if you scroll back up a little bit, you should see the two different standard deviations. So we have our SX, which is our sample standard deviation. Which equals 8.1. And then right below it, you have the little sigma x, which is our population standard deviation. Which is 7.7. Okay, so that's the stuff we can get from our calculator from that readout right now. Remember, we can determine the variance as well, so the sample variance is just our sample standard deviation squared. So in your calculator, you would just do 8.1 squared, which gives you 65.61. And then you can do the population variance, which is the population standard deviation squared. So you would just do in your calculator 7.7 squared. Which is 59.29. Okay, any questions so far? Going back up to mode to wrap this up here. So looking at it, we have a small data set here, so you could just look at the data to determine what the mode is. I think it's the 60 and 80. They both occur twice. But if we have a larger data set, there is a way where you can have your calculator put all your data in order, so it'll make it easier to see how many times each value occurs. So if you hit stat, so everybody do this in your calculator, hit stat, go down to the second option, which says sort A, hit enter just once, so it pops up on your screen and then your cursor is blinking right next to that parentheses. Then hit second stat, and select L1, so hit enter. And then hit enter again, and the word done should pop up on your screen. And then if you go back to your list, so hit stat and then enter to go back to your list, all of your data values will be in order. So it'll be easier to see how many times each one occurs. So this puts values in order. Okay. So I forgot one thing. One more thing we can determine from all of this information is the shape of the data without even having to do a histogram and look at it. Again, just by looking at the mean, median, and the mode here. In this case, we have two modes, and they're not really close to each other, so the mode is not going to be very helpful in this situation. However, our mean of 72.2 and our median of 73, those are fairly close together. They're only 0.8 apart. So in this case, our mean is approximately equal to our median, which means our shape would be symmetric or normal. Again, that's the same thing, so whichever name you prefer. Symmetric or normal is the same thing. Okay, that's it. So now you guys have the self-assessment. So go ahead and do that. Raise your hand when you're done. I'll give you the homework.